Okay, let's finally finish this assignment. All right, so we've got all the resistor values for this one. We want to get the total. So I notice 2 and 3 are in parallel. So I'm going to write out the steps to add these. Just step 1, 2 and 3 are in parallel. Okay, once you have that, that combination is in series with R4. So that's my next step. Okay, series with R4. And then that whole combination is parallel with R1, so that's step 3. Parallel with R1. And then once you have that, that's this whole branch here. That is going to be in series with R5. So that's my last step. Series with R5. If you follow all those, we should get a total of 9 ohms. Okay, so 9 ohms, V equals IR for the total, so it looks like 2 amps. So these numbers are working out nicely so far. Okay, so again, that total current is the current through the battery. I always check first thing, is there anything in series with the battery, because that's going to have the same current, and I see R5 is in series with the battery, so now R5 will also have 2 amps. And then V equals IR for R5, looks like R5 will have 10 volts going across it. Okay, so again, thinking about current, the 2 amps hits here, some will go this path, some will go this path. I don't know how that's going to split up, so I'm going to look at voltage. All right, so voltage, look at a single closed loop. I'm going to go, let's see, can I get Warren Blue Devil colors here? Let's see how the yellow shows up. Okay, so my first loop, I'm going to take, usually, the first loop I go with, I'm going to look for the least resistors I go through. Okay, so I'm going to take this path, I'm going to go up here through R1. Okay, all right, so I start out with 18 volts from the battery. And in my yellow loop, I have to lose all 18 volts. All right, so I'm going to go through R1 first. I don't know how much that's going to be, and then I'm going to go through R5, which that is 10 volts, and then that's it. I'm down to 0. So then V1 must be 8 volts. Okay, I don't know if I've emphasized this enough, but it really, to solve these circuits, it doesn't matter which direction you imagine the current flowing. I normally go clockwise, you could go counterclockwise, it doesn't matter, you're going to get the same answers. Okay, so back to this R1, we have 2 things, so V equals IR, we can get the current here, which is 0.67 amps. All right, so now, take your pick. You're going to think about current, you're going to think about voltage. It's up to you. So I don't want to mess this up any more than it will be. But if I think about another voltage loop, I'm going to come up here, I'm going to go through, let's say, R2, and then R4, and then R5. I'm going to have 2 unknowns there. Okay, so I don't know either of them, so I can't solve that. I can go through R3 and then R4 and then R5. Again, 2 unknowns, so I'm not going to be able to do that. All right, so let me look at current. Do bright red for current. Okay, so current, I'm going to look at a junction. Okay, so the current going into this is the junction I'm going to pick here. And then the current leaving that junction. Okay, so I know this is 2 amps. Okay, and then I know the current up here, I just solved for that 0.67. All right, and then this one I'll call it I4, and you may be able to look ahead and see why I'm doing that. But the current going into a junction, 2, equals the current leaving the junction, 0.67, and what I've called I4. So I4 must be 1.33 amps. All right. Now that 1.33 amps immediately, it's going to split up somehow. I don't know how, but it's going to come back together. So this will be 1.33 amps. Okay, and then we can double check at this junction as well. So 1.33, 0.67, they're going to combine to give us the 2 amps again. So we've got all that. Oh, why did that happen? There we go. All right. Okay, so V equals IR for R4. We can get that voltage. That looks like it'll be 4 volts. All right. Now the 1.33 amps, I don't know how it's going to split when it gets to this junction. So I'm going to go back and look at voltage. So I was going to try to do Blue Devil colors. I don't see a good royal blue here. Let's just go with this one. Turquoise. Perfect. Okay, so I'm going to start my loop at the battery. I'm going to take this path. I'm going to go through R2 and then R4 and then back home. Okay, so I start with my total voltage, 18 volts, what the battery gives us. Okay, first thing I do is I go through R2, which I don't know that one, and then I'm going to go through R4, which I just figured that is 4 volts, so minus 4, and then I still go through R5, which is 10, and now I'm back home. I should be down to 0. So if you solve that for V2, we should get 4 volts. Okay, so V equals IR, so this should be 0.33. All right, now to get our last piece, you can do whatever you want at this point. Actually, there's a few options you could do. You could look at a voltage loop going through R3, R4, and R5. You could look at the junction rule for current. I know how much current is coming in here. We said that was 4 volts coming in here. It'll get split between R2 and R3. Well, R2 gets 0.33, so then I know the rest will go down here. Or you could look at, R2 and R3 are only in parallel with each other, so if the voltage drop across R2 is 4 volts, I know R3 must also be 4 volts. Okay, and then let me go back to the current. So the current here, 1.33 amps. 0.33 goes this way, so I know this must be 1 amp. All right. So a lot of different ways for that final step. Use whatever makes sense to you. There's no incorrect way unless you do something incorrectly, I guess. All right, so to get the powers, solve an IV going across 5.36, 1.32, 4, 5.32, 20, and then 36. I'm going to double check, do all these add up to the total? They do, so we're in good shape. All right, so we're finally done with that assignment. As always, if you have any questions, shoot me an email. I'll put a copy of this on Canvas, as well as I worked it out separately. If you just want a less cluttered answer key to look at, you can look at that. Let me know if you have any questions.